start our last clip off here, or the beginning of the last clip, because we do some examples here and then we have a couple of articles to look at. So let's say, with Roman numeral 2, we wanted to look at how gender impacts pain levels on different levels for medication. So you wanted to look at how maybe gender and morphine work together. So do males and females respond differently to, no morphine or low dose of morphine? That would be a 2-factor ANOVA. You're looking at gender and dose of drug. Let's say you wanted to look at how race and income impacts attitudes about healthcare. Race would be one, not manipulated variable, but kind of a quasi-variable, a kind of a categorical variable. You could look at different races, maybe have 2 or 3 different levels. Income, you could have a few different levels. You might have 3 levels of each, so that would create a 3x3 design. A total of 9 cells. The DV would be attitudes about healthcare. So in a lot of these situations, you're actually interested in more than one independent variable. So if you turn over to the other side, and once again, this is just for example's sake, but it's the example I like to teach with. Let's say we're doing an experiment on motor performance. And let's say we're mixing, just for the sake of experimentation and statistical analysis, Xanax. Whoops, made a little mistake there. Sorry, I've had a little personal experience with Xanax. Oh, I spelled it backwards there, sorry. Mm-hmm. Bad joke. Okay. Peace.
That was a time.
Palindrome. Is 10 milligrams of Xanax the right kind of dose for Xanax? No, not at all.
That's a lot.
Cross the 0 off and make that a 1 for me, if you would.
72 ounces of alcohol.
I have more to say about that, but that wouldn't really be appropriate. So in this situation, I have how many independent variables here? 2. I have alcohol and I have pills, benzodiazepines. And how many levels does each one of these have?
Like 2?
Yeah, this is a 2x2 design. This is what we would call a 2x2 design. 2 levels of alcohol. College students, I don't know, 72 ounces of beer. What is that, a 6-pack or something?
It's a lot. Yeah.
That's a lot. Xanax, 0 and 2. It's considered a factorial design because basically here it's between subjects. You would have how many total people in the matrix I've created here?
12.
12. You've got 3 people who get no Xanax, no alcohol, 3 people who get 72 ounces of alcohol, no Xanax, 3 people who get 1 milligram of Xanax and no alcohol, and then 3 people who get 72 ounces of alcohol and 1 milligram of Xanax. Kind of the fun group. So this is a 2x2 between subjects design factorial. A factorial means all conditions are considered and everybody is only tested once. Could you do a before and after here? Yes, very much the case, but for the teaching purposes here, we just do this example. Is it a good idea to combine benzodiazepines and alcohol?
Doesn't look like it.
Doesn't look like it. I don't know, what was Marilyn Monroe on? Was it barbiturates and alcohol? Probably the case. So what do we know about Xanax, benzodiazepines, and alcohol? Is it a good idea to combine those products usually?
So we're assuming that motor performance, a higher number is better performance. That's the
Yes,
assumption.
I'm sorry about that.
Okay.
Missed the boat with that. The DV is motor performance. Pretend it was, and if you want to write this for your notes, walking on a white line 100 steps correctly. So the DV is motor performance, walking on a white line like a police test, 100 steps correctly. That's the DV here. Sorry about that. Thank you for asking that question. So, do you guys know, not even in a statistical way, is it good to give people benzodiazepines and alcohol at the same time?
Not usually.
No. What does that cause?
It appears in coordination. And decreased motor performance.
among other things.
And pharmaceutically speaking, what does it cause? It's a drug what?
Interaction.
It's a drug interaction. They're both working at the GABA receptors in the brain, and when you get too much GABA going on, you're in a lot of trouble. Alcohol and barbiturates, benzodiazepines, barbiturates more, but benzodiazepines both affect the GABA receptors, and that can cause loss of motor function. It can cause all sorts of negative impacts. So we know that when you combine alcohol and benzodiazepines, there's what's called a drug interaction. So is that, people are comfortable with that idea? I would assume people know that. So when you do a 2x2 situation, there are three statistical effects you can look for. And these three statistical effects may or may not be of real world interest, but these are the three. The first thing you can look for is you can assess, is there a main effect of alcohol? Is there a main effect? The term main effect is a statistical term. Is there a main effect of alcohol? And when you look at that situation, what you have to do is you have to say, okay, a main effect of alcohol, and if you want to even write this down, that is basically saying, okay, what are the two levels of alcohol?
None and a lot.
None and a lot. And you have to average, very important, average across the other variable. Average across the other variable. So if you're looking for a main effect, this is a statistical thing and it might not make much sense, but a main effect for alcohol statistically is basically saying, what is the effect of alcohol? Just not looking at the Xanax. So if you were to do that, for the people who got no alcohol, what's the mean for all the people who got no alcohol averaged across Xanax?
Who did get the Xanax?
So it's 90?
It's the 90. It's the 100, 100, 100. Sorry, I need my glasses. 76, 80, and 84. So it's the 180. MM stands for marginal mean. If you want to write that in, MM stands for marginal mean. So when people got no alcohol, the marginal mean was 90. How about when people got alcohol? What was the marginal mean?
50.
50. The 80 and the 20 is 50. So does it look like alcohol causes there is a main effect of alcohol? Yeah, 40-point drop, is that probably significant? Yeah, it's probably significant. So there's a 40-point difference, so there's probably going to be a main effect of alcohol here. Now whether or not that's really important to you is really up to you, but it looks like that'll probably be the way. So
So the second MM that's 50, can you just say, I guess I'm confused because I think 50 would be the mean whether it was going down the column versus across the bottom row.
yeah, it's going down. So the 80, that's the 72 ounces of alcohol. The 78, 80, 82. So the 80 is the mean for that cell. Sometimes it's useful to
So it's the
write
mean
the
of
cell
80 and
mean
20.
in each
so
one.
That one. So the two comparisons were
The 80 and the
marginal
20
mean
going
with
down.
No alcohol, marginal mean with alcohol.
Yeah.
Yes.
Okay, thank you.
So it's going down. What if I wanted to look, and maybe this will answer your question more, is there a main effect for Xanax, for benzodiazepines? What would you do with the matrix? Would you go down the matrix if you wanted to look to see, is there a main effect of pills?
Cross.
You go across. What's the marginal mean when you have no Xanax? Say it again. 90.
I do not know where you're coming from.
Roanoke.
No
Went
problem.
across the table, not down.
Yeah, so am I taking the average of the 300, the 3 times 100, minus the average of the 78, 80, and 82? That would be like 20. So where are we getting 90?
Let me try to make this, let's see. I pull up the agenda here. Agendas are good things.
Be averaging people without alcohol. figure.
I could.
Thank you.
So, should I start with the alcohol situation first?
Yes, please.
So, what you usually do is usually put the mean in for each group. It just makes it a little simpler to understand the logic. So for 100, 100, 100, the mean is 100. For 78, 80, 82, the mean is 80. For 76, 80, and 84, the mean is 80. And for 18, 20, and 22, the mean is 20. So the first question you would ask, is there a main effect of alcohol? Just visually inspecting things, what you do is you go down the matrix. No alcohol. So a main effect is saying, is there a main effect of alcohol? What is the effect of alcohol averaged across your other variable? You're not really looking at Xanax at all. So all you do is you go down the matrix. 100
Go
and
down the matrix.
Say-
So are you subtracting, adding, multiplying?
you add these two numbers up and you divide by 2. The mean of 180 is 90. And the mean of 80 and 20 is 50. So it looks like there probably is, statistically, we're just eyeballing it here. It looks like there is a main effect of alcohol. It looks like when you get alcohol, you're impaired. I'm sure people have personal stories, but we're teaching statistics here, so we'll keep that out. The second issue is there a main effect of pills? And so the question is, what would we do with the matrix there? So for pills, or benzos, we take the two levels of pills, no Xanax, the mean of no Xanax, I'm sorry I can't write it in here too well, but it's kind of the same thing again. It's 90 here for the marginal mean, and it's 50 here. Does it look like that'll be, is this making more sense?
Yeah, I just missed the mean part.
Okay,
I missed one step.
you missed the mean part?
Critical step.
Well, if you want me to be more mean, I can.
Okay.
I'm kind of,
It's essentially the same effect, more or less.
yeah, I made it
Based
that
on the
way
numbers that you made it
statistically.
easy, yeah.
I just made it easy for you here. So it looks like there'll probably be a main effect of pills as well here. So those are two statistical questions you can ask. The final question that you could ask, is there an interaction between alcohol and pills? Is there a main effect between alcohol and pills? So let me actually change some numbers in this for you for just, actually, no, I'll keep it the same. Does it look like the interaction, to figure out if there's an interaction, the idea, does it look like there's something special going on when people got the alcohol and the Xanax together?
Yes.
Special.
Isn't that special? It looks like motor performance is really impacted in a major way there, because the numbers go down to 18, 20, and 22. And the way you look to see if there's going to be an interaction is you make a graph. Oh, sorry, I can't fix the 10 there. Make that a 1. But you make a graph, and if you made a graph out of this situation, if the graph is non-parallel, you would consider it to be just visually kind of an interaction. It looks like there is indeed an interaction. Because in this case, actually, let me change a few numbers on you here, just kind of spontaneously. So go back to your, I'll change it on the picture here. So if we go back here, let's actually just take for a second the 1 milligram of Xanax and the 72 ounces of alcohol, and let's just say for the sake of example that the numbers here were 59, 60, 61. So 72 ounces of alcohol and 1 milligram of Xanax. What would be the mean for that group? 60. Would that indicate an interaction statistically? No, it would not. It would say, well, when you just give people 20 ounces of alcohol, how much does it decrease their performance? 20. When you give people 1 milligram of Xanax, how much does that decrease their performance? 20. When you combine them, 40. That is considered additive. If the effects of one variable on the other one are additive, you do not have an interaction. These lines would be how? Parallel. 100 to 80, 80 to 60. So in this situation, you would not have a statistical interaction. Does that work? But let's go back to the data that we had there before, the 19. Whoops. I can do it. 20 and 21. So the mean now is 20 there. And it looks like here, we know there's a drug interaction, so if we were to make the graph out, there's probably a statistical interaction. Comments or questions about this? Is just eyeballing things. Do you understand the three main statistical effects we can just visually look at here? Which one would be of most interest to somebody doing a study such as this?
The interaction.
The interaction. And would a person doing this study have a total of 12 people in here?
No.
No, because you wouldn't have enough what? Power. But for teaching statistics, this works. So,